In today's fast-changing global economy, competitiveness depends not just on size, but on the ability to innovate, adapt, and build skills. Industries worldwide are evolving. For Bangladesh, this is a defining moment, full of promise and responsibility. The next phase of growth will depend not only on production, but on how ideas become innovation. Yet, a gap remains between industry needs and skills. Without skills, innovation cannot grow. Without innovation, competitiveness cannot last. To address this, the government of Bangladesh, with support from the Asian Development Bank, launched the Skills for Industry Competitiveness and Innovation Program, SICIP, a national initiative connecting skills, industry, and innovation. At its core is BIRDI, linking research to real-world solutions. The response is promising, with innovative ideas emerging nationwide, many now supported under this initiative. This film highlights 12 such projects, addressing diverse challenges with one shared goal: innovation. From agriculture to advanced manufacturing, new solutions are improving efficiency, reducing waste, and creating value.
Bangladesh is a nation that feeds millions through its waters. With 25 lakh ponds across the country, aquaculture is not just an industry, it's a lifeline. But beneath the surface, a silent crisis is limiting the potential of our fish farmers every day. Feed costs takes up 60 to 70% of a fish farmer's budget, yet most still rely on guesswork. Overfeeding pollutes waters, while underfeeding slows fish growth. There is no real-time monitoring of water quality, making farms vulnerable. Climate-related losses alone reached $140 million in the last decade. The result? Wasted food, unhealthy fish, and lost income. This is exactly the challenge Happy Fish by Amarsource is designed to solve. Happy Fish is Bangladesh's first AI-powered, solar-driven, intelligently locally made fish feeder, built for our farmers and local conditions. Using computer vision and a smart hunger factor, it detects fish behavior in real time and feeds only when needed. Sensors track ammonia, temperature, and water quality, while a Bangla mobile app gives farmers full control. Unlike imported systems costing over 1 lakh taka, Happy Fish is locally built for thousands and making smart aquaculture affordable for all. The opportunity of Bangladesh is huge, and the impact has begun with Anower Agro Farm adopting Happy Fish. We target 10% less feed waste, 10 to 15% less labor, and 5% better FCR, powered by 30% solar energy. Beyond farming, we are creating skilled jobs and preparing students for the future of agritech. We thank BIRDI to give us the opportunity for sustainable and self-reliant future for the fish farmers of Bangladesh.
I welcome to our Project BIRDI Cold Farm from AN Enterprise. We are committed to build a practical, scalable solution for Bangladesh's agricultural supply chain. We introduced Project BIRDI, a small cold storage initiative designed for farmers and traders. In Bangladesh, up to 25 to 30% of onions or perishable crops are lost due to lack of proper storage. Farmers are forced to sell at low price during peak harvest, while consumers suffer from price spikes later. Traditional cold storage is expensive, large-scale, and inaccessible to small and medium traders. This gap creates massive economic loss every year. Our project offers a modular, container-based cold storage system, affordable, scalable, and deployable anywhere. Using a modified 20-feet container, we create a controlled environment with optimized temperature, humidity, and ventilation for onion and chili preservation. The system is energy efficient, easy to install, and can operate close to farms or markets. It allows small investors and traders to store their products for longer periods, reducing losses and stabilizing supply.
In our Ghana sector, a very significant problem is wastage of finished product due to different sort of faults in fact. For example, holes, stains, dyeing fault. So in the current system, they manually inspect a rolling fabric and try to detect it and then put some sticker or mark. So at the cutting stage, they identify these pieces of clothes and they remove it. So if there are some missing holes or missing faults, these go up to the finish stage, the final stage of the production, and then the final quality control chain, these are identified. So this causes a huge wastage of time and resource. So our target is to solve this problem using advanced computer vision technique in a cost-effective way. And for fast processing and edge device or Jepson Nano, so we'll mount these in a setup over the rolling fabric, and camera will take picture, and then in the real time we'll detect the problems and put some laser so that the human doesn't miss out defects, and they can put this sticker following the ray. So we believe this will significantly reduce the number of defects which currently remain unidentified. So these will be at the very early stage. The garbage people can take initiative and remove those defective parts, and also there will be some post analysis for the management. They can later identify which types of faults mostly frequently offering which type of fabrics, and so which sort of fabric is more cost effective to purchase. So this sort of decision making will be done easily.
All around the world, including Bangladesh, millions of people are affected by dry eye disease. Our research addresses this critical need by developing advanced, industry-ready ophthalmic formulations. With the BIRDI grant, along with Aristopharma and my research team at the Bioinnovation Research Group of the Department of Biomedical Engineering, BUET, we are developing a dry eye formulations to address the clinical challenges of dry eye. Studies show that over 90% of the conventional eye drops are cleared from the eye within minutes, and a very limited amount of drug is actually absorbed. This leads to frequent dosing, poor patient compliance, and limited long-term effectiveness. Through the BIRDI program, we are developing a nanoparticle-based eye drop designed to stay longer on the ocular surface and deliver drugs more efficiently. This means better therapeutic effect, reduced dosing frequency, and improve patient comfort. Looking ahead, these innovations will not only improve patient outcomes, but also drive high-value pharmaceutical development, strengthen local manufacturing, and position Bangladesh as a global leader in next-generation ophthalmic drug delivery. We warmly welcome you to visit us and be part of this transformative journey.
In the heart of the textile industry of Bangladesh, where millions of meters of fabric move every day, one question remains: can quality keep up with the speed? Together with Streamstack, IBA, Silk Flask, and Clifton Group, as our technical and industry partner, set out to find the answer. More than 20% defects go unnoticed. No trace, no certainty, no consistency. And the cost, waste, rework, and loss of trust. But what if machines could see, think, and decide instantly? It will not just identify defects, it will understand them, measuring size through segmentation and applying the 4-point grading system automatically. Fast, consistent, reliable. The future of quality is not just inspected, but assured. AI-based fabric quality control system. Because the future of manufacturing deserves intelligence.
We are proud to present a first-of-its-kind collaboration research between the Biotechnology and Genetic Engineering discipline of Khulna University and Incepta Pharmaceuticals Limited. BIRDI is the pioneer in Bangladesh to develop this research model. Biopharmaceutical manufacturing depends on specialized enzymes such as benzones, which is very essential for vaccine production. Currently, Bangladesh relies entirely on imported high-value enzymes, increasing production costs and limiting growth of domestic production. Despite strong academic expertise and a rapidly expanding pharmaceutical sector, structured industry-academia collaboration in Bangladesh is very limited. This gap constrains development of advanced biomanufacturing skills and slows the transition toward a knowledge-based bioeconomy. This project develops a scalable indigenous benzones production platform through collaboration between Khulna University and Incepta Pharmaceuticals. Khulna University will do the solution research, which will be implemented by Incepta. By integrating academic research expertise with industrial bioprocess infrastructure, the project establishes a unique and practical pathway for local production of benzoate enzymes. The initiative creates a model for biotechnology innovation linking research, process development, and industrial application.
Our project Sustainable Valorization of Cotton Waste into High-Value Cellulose-Based Product, led by me at BGM University of Fashion and Technology in collaboration with Sasha Denim PLC. This project is supported by BIRDI. It represents a forward-looking approach to sustainable industrial innovation. Together, this strong partnership between academia and industry working to reshape the future of Bangladesh textile sector. As you know, every year our textile and apparel industry generates a large amount of cotton waste. Unfortunately, much of this waste remains underutilized, contributing to environmental pollution and economic loss. But we see this not as a problem, rather than as an opportunity. Through advancement of scientific processes, we convert cotton waste into the high purity cellulose. This is further transformed into the high value materials such as cellulose acetate, cellulose carboxymethyl, cellulose nanocrystals, and cellulose citrate. These materials are widely used in global industries like packaging, pharmaceuticals, and advanced materials. This initiative supports Bangladesh's transition towards a circular economy. It helps reduce industrial waste while creating new economic value. By entering the rapidly growing market for cellulose-based green materials, Bangladesh has the opportunity to move beyond traditional textile export and expand into high-value sustainable product. The project will also create scale job opportunity for chemists, engineers, and technical personnel. It will strengthen research capabilities, promote industry academia collaborations, and help develop future-ready human resources. With the support of BIRDI, this initiative is a meaningful step towards a more sustainable, innovative, and globally competitive Bangladesh.
I lead TL Smart Factory, Bangladesh's first affordable digital twin for factory floor, made with BIRDI's support. Our garments industry earn 84% of our export revenue, but still most of the factories they run on paper tickets. They lose quarter of their production capacity every single day. The foreign platforms could solve this problem, cost almost 10 times than the factory can afford. This gap exactly where BIRDI exists. Without BIRDI, this project would have been still in a whiteboard sketch. Our solution is a mesh of low-cost IoT tally stations in workstations, streaming real-time data to the digital twin powered by AML machine learning. Across 300 stations, we can see every stoppage, every bottleneck in real time. It has three unique propositions. Number one, built in Bangladesh in 1/10 of the cost of any foreign solution out there. 2. The IP stays in Bangladesh. 3. It's not a lab prototype. In 12 months, it runs production with trained 68 Bangladeshi engineers. Scale this to 4,000 garments in Bangladesh, a production uplift of 25%. It adds billions to our GDP and also turns hundreds and thousands of operators to data literate engineers. With this, Bangladesh stopped being the cutting room of the world and become the smart manufacturing destination. BIRDI started this, Bangladesh finishes it.
Our EV conversion project is a collaborative initiative between Hasan University and Akis Motors. The project focuses on converting existing fuel-powered cars into electric vehicles. Bangladesh is facing rising fuel costs and increasing air pollution. Millions of fuel-powered vehicles are already on the roads. Replacing all of them with new electric vehicle is expensive and not practical for most vehicle owners. EV conversion faces a key challenges in fitting new components into limited space and managing heats inside the battery system. These problems make EV conversion less affordable and less reliable. Our project introduces two practical innovations to address these challenges. First, we replace the gasoline engine with the electric motor and battery system and retain the gearbox. This approach reduces conversion cost and increases efficiency. Secondly, we develop an innovative battery cooling system. As a result, battery life, safety, and reliability are improved. Our work is supported by modern laboratory facilities at Akis Motors and Hasan University. Our experienced mechanical and electrical team ensures the system remains practical, reliable, and affordable. The project has both economic and environmental benefits. The EV conversion can reduce cost, lower greenhouse gas emission, and improve urban air quality. The project can support the growth of the local industries. Most importantly, our solution provides a realistic pathway for Bangladesh to adopt electric mobility without replacing existing vehicles. We gratefully acknowledge the valuable support and guidance of the BIRDI team. Thank you all.
The semiconductor industry is one of the actively growing industries in Bangladesh. Unfortunately, its growth is hindered by the costly, time-consuming, error-prone manual design process currently in place. We, a team from BUET, University of Asia Pacific, Carleton University, and Dynamic Solution Innovators, DSI, are actively focusing on addressing these issues by automating RTL design and verification pipeline with the help of large language models.
Engineers today are currently translating the complex hardware design specifications into RTL codes manually, writing test benches to verify them, and then debugging them using limited automation. This results in very high design cycle, high costs, and low profit margin. This is actually unacceptable in current competitive market. Moreover, the off-the-shelf AI tools are not really ready for the current real industry problems. Our project aims to address all these issues.
We plan to leverage the code synthesis and reasoning capacities of large language models to automate the RTL design and verification pipeline. Here, we will first prepare a human-verified dataset and use this dataset to fine-tune the large language models. Models will first take the textual hardware specification, and from that, it will generate the RTL code and corresponding verification test benches. We expect that the proposed solution will be highly effective for the local industry because it will be co-developed and verified by our industry partner.
We believe that the successful completion of this project will significantly shorten the design turnaround time and thus improve the revenue. Not only that, it will also develop some local expert who will work for the end-to-end VLSI design and automation and contribute in the local semiconductor industry. As a whole, all of our expected outcomes will directly support productivity, skill development, and our broader goal of becoming a more efficient role player in the global semiconductor industry.
I am truly honored to have these BIRDI grants under SICIP initiatives, which we can consider one of the remarkable milestone of Bangladesh government, and I really appreciate the SICIP authority for their forward-looking initiatives. We all know that the traditional drying process in Bangladesh mostly rely on the human decision and operator experience, which consume a huge amount of water, energy, and other raw materials such as dyes and chemicals. This leads an inefficient dyeing in neat dyeing process. This is not only increase the production cost but also create an adverse impact in environment. This leads excessive use of water, energy, and dyes and chemicals. It also creates inconsistent shade prediction and frequent redyeing. These inefficiencies not only increase the production cost but also adversely affect our environment. To overcome this situation, we have proposed a solution that to develop an AI-driven smart control system to continuously analyze the critical dyeing parameters such as temperature, time, pH, and dye absorption using the advanced sensors linked to the machine learning models. Based on this data, it can predict the outcomes of the dyeing and adjust automatically what need to do and fix any variation to keep the dyeing process on the right track. We expect to achieve about 20% reduction in water and energy consumption, about at least 5% reduction of using dyes and chemicals, and at least 90% of shade accuracy. If we become successful of this project, we expect the overall dyeing production cost will be reduced about 15 taka per kg of neat fabric dyeing. That will be a milestone achievement for our country.
Think is a design, engineering, and manufacturing enterprise that makes automation machineries and industrial Internet of Things devices. We operate as a complete design house here in Bangladesh, covering everything from schematics design, circuit design, firmware development, embedded systems, mechanical design, and even semiconductor design services. Today we are proud to be working on a project called IoT Core, an industrial IoT platform designed to support the digital transformation of Bangladesh's manufacturing sector. Bangladesh's ready-made garments industry is one of the strongest pillars of our economy. However, many factories still lack the real-time visibility into their operations, whether it's machine performance, energy usage, production efficiency, or even maintenance needs. In many cases, decisions are still based on manual records or disconnected systems, making it difficult to detect downtime, inefficiencies, and wastage at the right time. As global competition increases, improving efficiency and adopting smart technologies is no longer optional, it is essential. Through IoT Core, we are developing a locally adaptable industrial IoT platform that connects machines, sensors, and energy systems into one unified monitoring and analytics framework. The system enables real-time data collection, intelligent dashboard, automated alerts, energy tracking, and even predictive maintenance insights. What makes our approach different is that it is designed specifically for the realities of Bangladesh: cost-sensitive deployment, modular hardware, and strong local service support. Instead of relying solely on imported systems that are often expensive and difficult to maintain, IoT Core aims to create a flexible, scalable local solution that improves efficiency, reduces downtime, and strengthens industrial capability. Through this project, we aim to deliver a complete industrial IoT ecosystem, including gateway hardware, monitoring modules, analytics platforms, and real-world pilot deployment in the garment sector. This will contribute to improved productivity, better resource utilization, and development of skilled technology capabilities within the industry. I would like to sincerely thank BIRDI and the SICIP program under the Ministry of Finance for their support. This grant is not just a support for Think. It is a strong step towards empowering local innovation and building technology solutions from Bangladesh, for Bangladesh, and eventually for the global market.
Local ideas solving real industry problems. And this is only the beginning. Many more are growing, ready to scale. Together, they signal a shift toward innovation-driven growth. Through SICIP and BIRDI, Bangladesh is investing in its people, ideas, and industries, building a more competitive future. In a changing world, those who innovate will lead. Bangladesh has begun that journey.